finally I'm making a new video, and it's about a topic that I care about a lot. Something that I have to remind myself is that when you build tooling for other developers, you probably should use those tools for yourself too, just so you can make sure they work. And so I thought I needed to actually write some RPG anyway for work, and I needed to expand our test repository that we use for some building. And I thought I would record myself adding new code, adding new RPG code to this repository basically, and actually show that you can use the tools to actually do development, which is really important, right? So let's start out by saying the goal here is that I plan on writing a brand new program, new display file to basically insert into a database. It's not particularly complicated, and then extend existing programs to use that new one. Let's talk about the tools that we're going to use. Obviously, as you can guess, VS Code. Pretty self-explanatory tool right there. Code for IBM handles all of the compiling, the building, the errors showing up, the useful stuff. We're going to use the renderer to look at and preview the display files before I build them. Very convenient tool. Of course, we're going to be using the database extension as well, because we are working with the database. We are inserting new stuff into the database too, which is kind of neat. And then the last two, which we're going to see right at the end, aren't necessarily part of VS Code. One is Source Orbit, and this is what handles all of the building of the application. So actually compiling the code from the repository, automatically generating the make file and compiling it, and doing all of the dependency management, does all the work for us. And then the last one is IBM CI, which really is just a CLI tool to run a set of steps against a system. And you'll see these last two tools being used primarily during the build phase of the development here, and also in the automation phase that we'll talk about right at the end. The first of three parts is really going to be us. I say us, I mean me, actually building the program. So, we're going to start out by building the base of the display file, which really means adding all the fields that we think we need for the program and the user. And as you can see in the video here, I'm using the IBM renderer to see the changes that I make in real time. It's kind of like building a web page. You want to be able to see the changes as you make them. Of course, the render isn't made to be a drag and drop solution. It's so I can edit the DDS and see the changes happen, in VS Code without having to compile and use SDA and all that kind of crap. Just kind of all in one situation there. So I started by building the base of the display file. That takes about 10 minutes. Building display files is an absolute nightmare, I feel like. Maybe that's just me. Maybe they're a little outdated. Maybe whatever. I don't like doing it too much. Luckily, I don't have to do it too much, but that's okay. A bit later on, we start building the base of the program. There's a lot to this program, kind of. Well, not really. We have to read in some fields, validate the fields, make sure the logic makes sense. And then we have to basically insert that data into the database. So after I start building the base, I basically am using the database extension to get some sample data from the database. And then following that, I'm writing the logic to generate an ID from the database using some really awful logic, because the sample database provided, I think this isn't really a DB2 thing, but the sample database that's provided to a lot of databases doesn't have an auto increment ID. And so I kind of just work with that, seeing as that's how all the existing logic is. So I write some logic to generate a brand new ID inside of my program. Not something I ever would recommend. Terrible, terrible idea. Let the database do that kind of stuff. Following that, probably a good time to start testing my program. So, of course, I can use 5250 inside of VS Code. I don't have to pull up any other separate windows to do my database work, to do my 5250 work. And you'll even see me a bit later on being daring and actually using Start Debug. I have no shame in admitting Start Debug is fine. It does the job, gets the job done. So anyway, I start testing my program. Following that, obviously validation, never trust the user input kind of thing. So I write some logic to handle validation from the user. And if there is any issues, then I return that the error to the display file to show it and render it on the display file as well. Convenient. The last bit of major work is after the validation has happened, inserting the data into the database. So I'm using fully embedded SQL, no record level access here because it's 2024. So I take the input fields from the display file, stick them into a struct, the employee struct, and then whack it in the database. Pretty common scenario. And then lastly, for this part, building the new EMP program, with the new database is actually seeing it fully working. So, I'm able to launch the green screen, set up my environment. So setting the library list, call the program, enter in the fields, and really the result is that it ends up in the database. And to check that it ends up in the database, I of course can use the database extension. Don't have to leave the IDE to do that. Okay, cool. Easy peasy. Of course, I put this into Git as well. Done and dusted. Next part is actually calling the insert employee program, new emp, from a different program called departments. So departments is just a list of departments, and departments can hold employees. And so I start by adding this new parameter to new emp. And I pass in the current department that I'm working with to new emp, and you'll see that in a bit. And so then I test the logic, which really just means doing an 8 against the departments program, which we'll call the new employee program, and we're done. Not particularly complicated. And the last part is, of course, putting that work into a new branch. This is important. Of course, I don't want to push it to main like I did with the last change that I did. Actually, I didn't. I just didn't show the PR being created, but I'm putting the work into a branch now. And the reason I'm putting it into a branch is because I'm going to let Source Orbit and IBM CI do a bit of testing for us just to make sure it builds properly. It can find the dependency lists and can do all the work for us automatically. Which is what brings us on to the last part, which is the automation side of things. So we're going to swap over to GitHub here and we're going to do a couple of things, right? First off, I'm going to create the PR. Very most important piece. This really just says that this code is ready for review. It's ready to be tested, by somebody else, maybe by QA, by another developer, whoever you like to get things tested by. That's fine. And after the PR has been created, a couple of things are going to happen automatically inside of a GitHub action. And I have a workflow already defined in this repository for this. And what's happening is it's running, what is a generic term, but it's just called an impact report. And what this does is for the people that have code bases where they have like 10,000 programs and 100,000 files. That was an exaggeration, obviously. But, they have all these objects. And so the impact report is supposed to show users kind of like, well, you may have made a change to this one file, but you've actually gone ahead and broken not broken, but you've basically caused like a level check down the line somewhere. And so the impact report can kind of show you, you change this file, you change this table, and you're going to have all these other things need to be rebuilt, which is cool. We can do that here. And then the last part to this workflow is the automated build. So the really cool part about IBM CI is that it's stupid. It's really stupid. You can take, how do I put it? You can take the generated makefile from Source Orbit, the same thing that generates the impact report, and pass that down the line. You can tell IBM CI to upload the new makefile and all the files to a remote system, like a test system or a compile box, and do a build over there automatically. That's great. And you can even make it build into a branch library. You don't have to keep building into the same library every time. You can have unique libraries for each build, which is kind of makes sense because it's in a separate branch. It's supposed to be a unique branch. So that's pretty cool. We can completely automate the impact information. We can completely report the build, not report, we can completely automate the build, and you can see it directly in GitHub, which is really cool. So not only are we able to do all of our development inside of VS Code, but we can also completely automate the impact info and the build using pretty much any build tool you want. Like, it doesn't even have to be GitHub Actions. It can be Azure, it could be Jenkins, it could be, whichever. Pick your pick, and Bob's your uncle. I mean, it just kind of works. It's just generic tools, right, that work with Git, and it's not particularly complicated, I guess. But anyway, short video, I'm guessing, by the length of this recording, but I hope it was interesting anyway.